to determine these limits. So I'll say limit as x approaches -1 from the left of x minus 2 over x plus 1, and limit as x approaches -1 from the right from x minus 2 over x plus 1. When I plug in -1 here, at the top I did -3. Would you agree with -3 at the top? But I have a big problem with the denominator. I have -1 plus 1 and -1 plus 1. What is that? Yeah. Right. So I know that this is trouble, meaning the limit does not exist. But there are three options of not existing: positive infinity, negative infinity, or excellent. So -1 from the left is -1.1. I only want the sign here. Negative. Negative of a negative is -1 from the right, meaning -0.9. -0.9 plus 1, I only want the sign. Yes, so negative of a positive is? So, negative infinity, positive infinity. So what does x equals -1 represent for this function? If the function does this, or does this, or this, or this. Vertical asymptote. Okay, let's find the first derivative. F prime of x. Remember, we have to use the quotient rule. The top function prime, how much? 1 times the denominator minus the top function times the denominator prime, 1, over the denominator squared. Excellent. Okay. X plus 1 minus x plus 2 over x plus 1 squared. These two go away. 3 over x plus 1 squared. Nice. Is this ever 0? Because now I have to find the critical numbers. Is this ever 0? Never 0. So f prime of x, not 0. Is f prime of x, so this is for critical numbers. F prime of x undefined? Yes, it's undefined at but so is the function. So there are no critical numbers. None. So f prime is undefined at -1, but the function is undefined at -1. No critical number. I need the sign of this expression. Can anyone give us the sign of this expression no matter what? Positive. Very good. Awesome. What does that say about the function? Forever. Increases. Forever increasing. Now I have no idea whether my calculations are right or wrong. Now at this point, I will have to make sure that these two rows work well together. If they don't, I have errors. So, from 1 to infinity, what does the function do? Increases. Is that supported by the first derivative? The sign of the first derivative, yes. From -infinity to -2 to 0 and to 1, what does the function do? -infinity, -2, 0, 1. Increase. Is that supported by the sign of the first derivative? Yes. Awesome. Final step, the second derivative. So this was the first derivative. What do you think I'm going to do to this? I refuse to differentiate this. 3 times x plus 1 to the so 3, so f prime, 3 times x plus 1 raised to the, but there is no square root.
Negative?
Yes? Exactly. Isn't this easier than differentiating that?
Yeah.
Very good. So let's differentiate. So the second derivative will be, bring down negative 6, x plus 1 raised to, very good, times the inner function prime. But how much is x plus 1 prime? Very good. So now I'm back to is this ever zero? A fraction is zero only when the top is zero. But now I have to be very careful with the sign. So to the left-hand side of negative 1, like negative 10, plug in negative 10 and tell me the sign of this whole thing. Negative 10 plus 1 is negative 9. Negative 9 to the third is negative, with negative in front. Excellent. The function has to hold water. On the other side, let's plug in 0. 0 plus 1. 1 cubed 1. 6 over 1 with minus in front. That's all we needed. We filled out the chart. This will help us graph it right now. Ready? When we graph a function with asymptotes, what do we need to graph first? The asymptotes, very good. So there is a horizontal asymptote at 1, y equals 1, and a vertical asymptote at negative 1, x equals negative 1. So I have to write those on the chart. Y equals 1, horizontal asymptote, 1, and x equals negative 1, vertical asymptote. Okay, ready? I have 0, negative 2, 1, 2, and 0 and 2, 0. I only need my chart. Ready? It's coming from approaching 1, increasing, opening upward towards infinity. Okay, no problem. On the left-hand side of the asymptote. On the other side, on the right-hand side of the vertical asymptote, it's coming from negative infinity, increasing all the way, opening downward, crossing at 0, negative 2, crossing at 2, 0, and approaching 1. All the time increasing and all the time opening downward. So this is the function f of x, x minus 2 over x plus 1. And I should have written here, please do that, go back for a second. F of x, what was it? X to the third minus 3x squared. Was it minus 144x or plus here? And minus 140. Okay, so please write, always write the function somewhere. Any questions? Any questions? Yes?
So I can tell from my graph that my negative 1 is my vertical asymptote, but how can I tell my other asymptote just by looking at my graph?
Very good question. When we determine the end behavior of a function, like we did with the polynomial in the previous example, we plug in sort of like in infinity, right? So here we have negative infinity, on the other side positive infinity. For the rational function, we have to do that trick, factor out the degree and simplify. So then if we get a number, then there is a horizontal asymptote.
Okay, I understand.
Any number. But if it's infinity, it's not a horizontal asymptote.
So it wouldn't have mattered if we had 2 and 2. 2 would have been my asymptote.
Correct. Okay. Correct. Now, not in this class, though. But there are functions that have to negative infinity, negative 3 as a horizontal asymptote, and to the other side, positive 3. But not in this class. So that's possible. But we have not, that's what I said, we have not make use of the sign of the infinity. If we don't make use of the sign of the infinity, the same thing happens at both ends. But again, not in this class. But with my other class, yes, we have those examples. Okay, I would like to look at a word problem. And we can also work on another problem. We only have 10 minutes left, so we can work on another problem like this so you get the hang of it next time with pleasure. But I like to work on a word problem now. So so let's read the titles and you choose. Purchasing power, medication in the bloodstream, total cost and revenue, cost of pollution control, average cost, depreciation. What are you interested in?
Depreciation.
Increasing what?
Depreciation.
Depreciation again. Okay. Very good. So we have the depreciation problem is 58 on 231. 58 on 231. Suppose that the value V of the inventory, blah, 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 in hundreds of dollars. V, hundreds of dollars. Decreases, depreciates after T months, and V of T, so T is in months, 50, V of T equals 50 minus 25T squared divided by T plus 2 squared. So now I will immediately ask you what type of function is this, and you would have to say, absolutely, it has a ratio and it has the variable in the denominator. It must be a rational function. So let's read on. Find V of 0, V of 5, V of 10, V of 70. In part A, I'm going to ask you to do that. If we have time, we'll come back. So it says V of 0, V of 5. Of course, I will put the function in the graphing calculator. V of 10, V of 70. You want me to do this? If you say yes, I'll do it now. The next question, you'll make a decision in a second. Find the maximum value of the inventory over the interval 0 to infinity, of course. Time is in months, so 0 to infinity.
Find maximum value of the inventory.
Okay, so you can plug in the function these numbers and get the answer, correct? Mm-hmm. Okay, so in part B, we want to find the maximum. Max for V of T. How do I do that? Of course. So let's find V prime of T. So when I differentiate 50, that goes away. The negative 25 do not involve negative 25 in the calculations because you're just increasing the numbers for no reason. So you can now just look at this. The top function prime. Very good. Times the denominator minus T squared times the denominator prime over the denominator squared. So square the denominator for me. Copy the base, multiply the exponents. I have to square this. 4, right? Perfect. So now I have to differentiate. 2, I rushed. I'm going to put it here. 2 times T plus 2 to the first power times the inner function prime, which is? Perfect. So let's do this one more time for everyone to see, because I feel like I rushed through it.
Yeah, I don't understand how you did that.
Very good. So is that clear that I keep negative 25 outside? Okay. When I differentiate the top, I get 2t, and then I have to copy the bottom. Quotient rule. Minus. I copy the top, but I have to differentiate the denominator. When I differentiate t plus 2 squared, I have to bring the power in front and subtract 1 from the power and multiply by t plus 2 prime. Luckily, is 1. Does that make sense? Should I say it again? Is that a yes or a no?
And then the t plus 2 squared at the bottom, you just square it.
That's the formula. Let me refresh your memory on this. So when we have a function divided by another function prime, we must use the quotient rule, which is 1 prime times 2 minus 1 times 2 prime over 2 squared. That's the rule. The denominator is not differentiated, it's squared. So when I have t plus 2 squared and I square that, copy the base, multiply the exponents. Is this okay?
Yes.
Okay. Of course, I have to perform calculations here. Okay. I will definitely factor out. So I have a negative 25, 2t, and a t plus 2. 2t and t plus 2. T plus 2 to the 4th. Let's do this together. You can say, why don't you just, no, that will be brute force, too much work to do. So I see this term and I see this term, and I have 2t and 1t outside. There is a t plus 2 and a t plus 2 outside. So from the first term, 2t is out, 1t plus 2 is out. What is still left in? Very good, awesome. Then I have to copy the minus. I only reached the stage right here. I took a 2 outside, I took a t outside, and I took a 2 plus t plus 2 outside. What is left from this whole thing? That's it. Excellent. What do you think? Look at this, all this expression, and what do you think I'm going to do next? I know you know the answer. Negative 50 t times 2 over t plus 2 to the 3rd. Negative 100 t over t plus 2 to the 3rd. See the power of factoring? Otherwise, I would have factored and distributed and so on and so forth. So this is the final derivative. Do I still have a minute? Yes, I do. Okay, so we found the derivative, and now we want to find this maximum. It says, find the maximum value of the inventory over in the interval 0 to infinity. So, of course, this is never undefined, or 0 to infinity, because t plus 2 is never 0. This will be 0 and negative 2, but that's not in the question here. And we cannot go back 2 months. We wish. Okay, so the only option I have here is to say v prime of t equals 0. And the only answer is for the top to be 0. Not negative 1 and not 100, but t equals 0. So this is going to give us absolute maximum. We'll see. V prime of t, 0 to infinity. I didn't mean that. This is v prime of t. Okay, so good. So what should the sign be here? Because if it isn't, this is not going to give us a maximum. But if beyond the 0 is positive, then this is not local max. It's not the absolute max, not local. It's at the end of the interval, right? So what should the sign be here? Let's say we don't know. Let's look at the sign. If I plug in this expression any x value to the right of 0, not 0 of course, what sign will I get? Positive, positive, positive. Always. It makes sense, right? Because it should go increasing and then decreasing. So this will be definitely the maximum.